This is the video for 13E, finding areas using integration. So the chapter starts off with an explanation from first principles, of how the area under a function can be found by integration. And that's given a function of x, the area under the curve between two values of x can be found by integration. You don't need to know why, you don't need to prove it, but we need to know that area means integrate between two variables. So we need to know that. The first example says find the area between y equals 20 minus x squared and the x axis. Well, it's always a good idea to sketch so that I can see what function I'm talking about, so that I can see my limits. Now I can see that this is a negative quadratic, so I'm going to write it in the order that I like it to be written. Of course, I need to find my roots because I know it's going to be an upside down parabola. I need to know where it crosses the x-axis. So if I set to 0, this isn't new, we've seen this before, solve this quadratic. This factorises nicely, plus 5 and minus 4. So I can see that my roots are minus 5 and 4. Good, that enables me to sketch it. I know it's a negative quadratic, I know the roots, so of course they're going to be my limits. Minus 5 and 4, and it's a parabola, so this is the area that I'm trying to find. So here my area is the integral between minus 5 and 4 of my function. Well, this is now a straightforward definite integration. Square brackets, integrate. No simplification to be done here, so straight to my calc button. Minus x cubed over 3 minus x squared over 2 plus 20x. Now I want to calculate at 4. 1, 5, 2, 3. I want to calculate at minus 5. So I'm subtracting minus 425 plus 6. So I add, minus 425 over 6. And my answer is 152 over 3 plus 425 over 6. 243 over 2. For 13E, every single one's going to be like this. 13D, we start looking, 13F, we're going to start looking at areas below the x-axis. But for 13E, every single one's going to be one of these. Okay, see you next time.